This is section 5.3, part C, tree diagrams and the general multiplication rule. Another way to model chance behavior that involves a sequence of outcomes, like tossing coins, is called a tree diagram. In probability, a tree diagram may be used to represent a probability space. Tree diagrams may represent a series of independent events, such as a set of coin flips, or conditional probabilities, such as drawing a card from a deck without replacing the card. So on this example on the right, you have a coin and you toss it. For the first toss, you have 50% chance of getting a heads and a 50% chance of getting tails. Now let's say you flip the first coin and you do get a heads. Now after that first flip, you're going to flip it a second time. You have a 50% chance of getting a heads the second time or a 50% chance of getting tails. If on that first toss you actually got a tails, then for your second toss you can get a heads or you can get a tails. Now let's say you get a head both times. The probability of getting two heads, you had a 50% chance the first time and a 50% chance the second time. So you would multiply those two probabilities together to find the probability of getting two heads would be 1 out of 4, or a 25% chance. Let's return to Mr. Tabor's AP Statistics class from our previous Check Your Understanding. The two-way table shows the gender and handedness of students in the class and is repeated below. So suppose we choose a student at random. Draw a tree diagram that shows the same sample space for this chance process. So again, our student that is selected can either be left-handed or they can be right-handed. The chances that they are left-handed is 4 out of 28, and the chances that they are right-handed are 24 out of 28. So we're randomly selecting that first student. The chances that they are left-handed is 4 out of 28, right-handed is 24 out of 28. If the first student we select is left-handed, the chances that the next student is left-handed, there will only be 3 students left who are left-handed out of 27. If the first student is left-handed, the chances the second one is right-handed is 24 out of 27. If the first student is right-handed, the chance the next person is left-handed, there's still all 4 left-handed people left, only 27 students. But if the first one is right-handed, the chance that the second one is right-handed, there'd be 1 less right-handed person to select from, so there's only 23 out of 1 less student, which would give us 27. Find the probability that both students are left-handed. So if we come back up here to our tree diagram, if the first person is left-handed, we went this branch, so we had a 4 out of 28 chance. And if the second student is left-handed, we've done this branch of our tree. So in this case, we have 4 out of 28, and then we have a 3 out of 27. So the probability is 12 out of 756, or approximately 0.016. So there's about a 1.6% chance of randomly selecting 2 left-handed students. So our general multiplication rule says that the probability that events A and B both occur can be found by using the general multiplication rule, which says the probability of event A and B is equal to the probability of event A times the probability of event B given that A has already happened. Now, if these two events are independent, remember the probability of event B given A is just the probability of event B, such as when you're flipping coins. So the Pew Internet and American Life Project finds that 93% of teenagers who are ages 12 to 17 use the internet, and that 55% of online teens have posted a profile on a social networking site. What percent of teens are online and have posted a profile? Explain why this answer makes sense. So we can first start by making a tree diagram. Are the teens online or are they not online? So online students or online teens and not online teens. We know that 93% of them are online, and we know that 7% of the teens are not online. Now, of the students who are online, we know that 55% of them have posted a profile on a social networking site, which means that 45% of them have no profile on any social networking sites. So what are the percent of the teens are online and have posted a profile? So we would take these two probabilities and we would multiply them together, and we would get 0.5115, or about 51% of all teens use the internet and have a profile on a social networking site. Video sharing sites such as YouTube are popular destinations on the internet. Let's look only at adult internet users who are aged 18 and over. About 27% of adult internet users who are 18 to 29 years old. Another 45% are 30 to 49 years old, and the remaining 28% are 50 and over. The Pew Internet and American Life Project finds that 70% of internet users aged 18 to 29 have visited a video sharing site, along with 51% of those who are aged 30 to 49 and 26% who are aged 50 and older. Do most internet users visit YouTube and similar sites? So we're going to start our tree with actually 3 different branches to start out with. We have 18 to 29-year-olds, we have 30 to 49, and we have 50 and up. Of the 18 to 29-year-olds, 27% use the internet. Of 30 to 49-year-olds, we have 45% use the internet, and 28% of 50 and up. Now, of those who use the internet, they can either visit video sharing sites or not visit video sharing sites. So yes or no. So of the 18 to 29-year-olds, 70% do visit video sharing sites, which means 30% do not. 51% of 30 to 49-year-olds do, so 49% do not. And 26% of people who are 50 and older visit video sharing sites, while 74% do not. So do most internet users visit YouTube and other similar sites? So if we find the probabilities of yes and yes, so they're on the internet and they visit video sharing sites of all 3 age groups, we can then add them together. So on the first one, we have 27% of the age group, and of those, 70% watch video sharing sites. This would give us 18.9%. Of the 45% of this age group, we know that 51% of them do watch video sharing sites. So this would give us 22.95. And 28% of this age group gets online, and 26% of them watch video sharing sites, which would give us 0.0728. If we add those categories together, because we want to know all together in all the age groups, we're going to get 0.4913. So do most internet users visit YouTube and similar sites? The answer would be no, because it is less than